Hi, boys and girls. This is Miss Johnson. Today we are going to be talking about sound and sound energy. Please make sure you are following along with your guided notes. Anything written in blue on the PowerPoint needs to be filled in on your guided notes. Some facts about sound. Sound is a form of energy produced and transmitted by vibrating matter. Sound travels in longitudinal waves. Sound travels more quickly through solids than liquids or gases. These are called mediums. Remember that a medium is matter or material. Compression and rarefaction. We have talked a little bit about compression and rarefaction when we talked about the parts of a longitudinal wave. Compressions are where molecules are being pressed together or smashed together as the sound waves move through matter. For example, a wave travels through the springs just like sound waves travel through the air. The places where the springs are close together are like compressions in the air. Rarefaction is where the springs are pulled apart. Take a look at the four diagrams below. You will notice in the first diagram, at the beginning of this longitudinal wave, the springs are compressed. Then the springs get further apart as they become rarefaction. Sound waves. All sound is carried through matter as sound waves. Sound waves are alternating areas of high and low pressure in the air. You may remember learning about high and low pressure last year in 5th grade when you learned about weather. Sound waves move out in all directions from a vibrating object. Wavelength and frequency. Wavelength is the distance between one part of a wave and the same part of the next wave. We have learned that wavelength is the distance between one crest to another crest, one trough to another trough, or one compression to another compression. Frequency is the number of waves moving past a point in one period or second. Take a look at the diagram to the right. The top wave has a higher frequency because it has a shorter wavelength. The bottom wave has a lower frequency because it has a longer wavelength. Pitch. Pitch is a measure of how high or low a sound is. Pitch depends on the frequency of a sound wave. For example, if you look at the diagram all the way to the left, you will notice that it has a low pitch, low frequency, and a longer wavelength. The one in the middle has a medium pitch, a medium frequency, and a medium wavelength. And the one all the way to the right has a high pitch, high frequency, and a shorter wavelength. Sonar. This is a new word we're going to talk about. Sonar is an instrument that uses reflected sound waves to find underwater objects. For example, look at your diagrams. Animals use sonar or echolocation to find their prey. These sounds have such a high pitch or frequency that the human ear cannot hear. Humans also use sonar to locate or map objects. Interactions of sound waves. Reflection. A reflected sound wave is called an echo. The harder and smoother the surface, the stronger the reflection. If you remember back to our heat energy unit, we learned that reflection was when light waves bounce off of surface. We also now know that it's also when sound waves bounce off a surface. Diffraction. Sound waves can diffract or bend around corners and then spread out. Last unit, we learned that refraction was when light waves looked bent. This is kind of about the same thing with sound waves. Measuring waves. Although we've already went over this, we are going to go over it a little bit more. Crest is the highest point on a wave. Amplitude is the volume of a wave or the height of a wave. As the wave height increases, the volume will also increase. This is measured in decibels. You will watch a Study Jams video after filling in your guided notes and watching this PowerPoint that'll go more in detail with this. Trough is the lowest point on a wave. Frequency, pitch, high or low, is the length of a wave. As wavelength increases, pitch decreases. This is measured in hertz. Amplitude versus frequency. What's the difference? Amplitude. Take a look at the diagram below. Which one of these waves do you think will have the higher volume? Make sure you look at the amplitude. Frequency. Which wave do you think will have the higher pitch? Sound and instruments. Wow, I bet you didn't know that they went together. Instruments can be played at different pitches by changing the lengths of different parts of the instrument. For example, another way to make different pitches is to change the thickness of the material that vibrates. For example, a trombone's mute absorbs some of the sound waves produced, thus producing a softer note when played. Remember, sound is a vibration. Vibration is a back and forth movement of molecules of matter. Look at the diagram below. The first diagram is a tuning fork. This is pure sound. The second diagram is somebody hammering a nail. That is just noise. How we hear, the ear. Sound is carried to our ears through vibrating air molecules. Our ears take in sound waves and turn them into signals that go to our brains. Sound waves move through three parts of the ear: the outer ear, middle ear, and inner ear. Take a look at the diagram below. We will go more in detail about parts of the ear at another time. And that's all. I hope you know a little bit more about sound now. Remember, we will discuss this in class in just a couple of days.